All right, so let's apply what we've learned. So here we've got an equation with a bunch of initial conditions. So we can set up our auxiliary equation, which is 4m squared plus 4m plus 17 equals 0. And then I want to use the quadratic formula and kind of see what our solution for m looks like. So m equals -4 plus or minus the square root of 4 squared minus 4 times 4 times 17 all over 2 times 4. And if we work that out, so that's going to give me -4 plus or minus the square root of -256 over 8, which is -1/2, plus or minus, let's see, 256 square root. So that's -16i over 8. So I get -1/2 plus or minus 2i at the end there. Okay. So let's put that into our general format from before. So that means our solution is going to look like e to the -1/2 x, and then c1 cosine 2x plus c2 sine 2x. Alright, so from here we can apply our specific conditions. So y of 0 equals -1. So that would be -1 equals e to the -1/2 times 0. C1 cosine of 0 plus C2 sine of 0. Okay, so a lot of these are just are going to zero out. So, well, this piece right here, e to the -1/2 times 0, that's just 1. So we get -1 equals 1 times. Cosine of 0 is 1, sine of 0 is 0. So that just gives me C1. Okay, so I now know C1 is equal to -1. Hooray. Then if I want to find C2, so I got to use that other information. Probably want to crank out the derivative here. So y prime. And actually, I lied. What I want to do is I want to take, since I know C1, I just want to plug that in. And then I want to take the derivative, and then I can apply the other condition that we know, because that makes my life a little bit easier if I now know that C1 is -1. So cosine 2x plus C2 sine of 2x. Alright, so this would be an example of the product rule with a bunch of chain rule joy going on there. Okay, so it occurred to me I needed to have a little bit more space, and this function's a little on the complicated side, so taking pity, I split it up so it's a little bit easier to take the derivative of. Okay, so y prime, and I'm going to do a little bit of color coding here so that I can refer to the purple one and the blue one and the green one. Maybe make it a little bit easier. Okay, so I want the first, so e to the -1/2 x times the derivative of the second. So derivative of negative cosine, well, derivative of cosine is negative sine. So negative sine of 2x times 2 because of chain rule. And then I want the second, so negative cosine of 2x times the derivative of the first, which is negative 1/2 e to the negative 1/2 x. All right, and then plus, kind of repeat myself here, so the first, so e to the negative 1/2 x times the derivative of the second, so that's c2, derivative of sine is cosine 2x times 2 plus second times the derivative of the last, which is negative 1/2 e to the negative 1/2 x. Okay. And keep in mind, I'm putting 0 in for a lot of this. So some of these things are just going to become 1s and some are going to become 0s. So I can do a little bit of canceling, sort of focus on the stuff that really is going to matter at the end. Let's see. The 0s are going to be sines. So anywhere I see a sine, that whole thing is going to be 0, and I can completely ignore the rest of it. And then the other stuff, so that's going to be a 1. That's going to become a 1. That'll become a 1. That'll become a 1. And there we go. Okay, so hopefully I got this cleaned up enough that we can solve for C2. So 2 equals, looks like 1 times 1 times a half, so 1/2 plus 2C2. Okay, so then we just need to solve for C2. So that would be 2 minus a half is 4/2 minus 1/2 equals 2C2. So 3/2 equals 2C2. So C2 would have to be 3/4. All right, so let's try to put this together in our complete equation here. A little more space. Okay, so we got y is equal to e to the negative 1/2 x, and it's negative cosine 2x plus 3/4 sine of 2x. Yay.